Hello everyone and welcome to the histograms. So in this video we are going to discuss one of the most known visualization of numerical or quantitative data. It's most common, it's called the histogram. So a histogram is a graph used to display numerical or quantitative data. It shows how data distributed across intervals or bins. All right, so if you have a histogram, then we can talk about the shape of the data. Maybe we have like a right-skewed data or a left-skewed data or a symmetric data. So we can talk about the shape of the data. We can also look at where values are concentrated. And it could be also, we may find outliers based on the histogram. If you see like some data are far away from the majority of the data, then based on this histogram, we can detect the outliers. All right, so the histogram consists of x-axis and y-axis. In x-axis, we have to list the intervals or the bins. In y-axis, we list the frequency or relative frequency. It depends to the scenario that you have. And then we have bars. And the height represents how many values fall into each interval. So I will show you an example in the next couple of slides. All right, so we have a frequency and relative frequency histogram. So the frequency histogram shows the number of observations in each interval or in each bin. The relative frequency histogram shows the proportion or percentage of observations in each bin. So they are equivalent. The frequency and relative frequency histograms are equivalent. They have the same shape, the same bins or intervals. The only difference is the y-axis. In the frequency histogram in y-axis, we have the frequency or the count, which are the numbers like 0, 1, 2, 3, 4, and so on. In the relative frequency, we have percentage or proportions like 10%, 20%, 30%, but they are equivalent. They have the same shape, remember, same shape and same interval, which means same x-axis, but y-axis is different. Right? So we have common shapes of histograms. So we may have like symmetric, right-skewed, left-skewed, or uniform histogram. So let me give you like a small diagram of each scenario. For example, if your histogram looks like this, suppose this is x and this is y. Let's say y is the frequency and x like number of students, right? So let's say you have interval like this. This is your bars. In the histogram, the bars, they touch each other. So this is an example of a right-skewed histogram. So we say right skewed or skewed right. So this is right skewed. Because if you want to add a curve, so the long tail is on the right-hand axis. So this is called right skewed histogram. All right. Similarly, if you have this shape, this is called left skewed. Left skewed. because if you add a curve, then the right tail is on the left-hand side. Now, sometimes all bars approximately have the same height. For example, let's say this is our first one, this is the second, this is the third, this is the fourth. So all of them approximately have the same height. So this is called uniform histogram. Okay, uniform histogram. The last one is the symmetric. So when you have something like this, it looks like the normal distribution. So this is called a symmetric histogram, symmetric. So for the symmetric histogram, if you add a curve, you should have something looks like the normal distribution curve. So for example, this is the peak. So as you see here, the right-hand side is similar to the left-hand side. So we can say this is a symmetric histogram. All right, so again, we may have right-skewed histogram, left-skewed histogram, uniform histogram when all of the bars, they have approximately the same height, or symmetric histogram. Let's look at this example. Suppose we record the number of hours 20 students studied for each exam, and we have this data set, 2, 3, 5, and so on, and the question is draw the relative frequency histogram. Of course, you can use a software to do that. You can use Excel, you can use R, you can use Python, you can use any software, but here I will show you how to do it by hand, all right? Okay, so we have to determine like the width of each bin or the size of each bin. So for example, let's use bin of width 4 hours, right? So this means I have, let's create like this table. So this is for the hours. Let's say 0 to 4, because I want to use 4 hours. 0 to 4, 4 to 8, 8 to 12. The maximum value is 20, so I have to keep going. 12 to 16, and the last one 16 to 20. So in this case, I have 5 intervals. If you need more intervals, like 6 or 7 intervals, you make this smaller. So for example, maybe 0 to 3, 3 to 6, and so on, all right? So this is the hours. Then we have to look at the frequency of each bin or each interval. So this is frequency. The question asks about relative frequency, but to create the relative frequency, I have to create the frequency first, and the relative frequency is the proportion, which means I have to divide the frequency by n, and n is 20. So first I have to calculate the frequency. And then the next column, it's relative frequency. Relative frequency. Now 0 to 4. And the next is 4 to 8. Now 0 to 4, does 4 included here or here? So the general idea here, the most common one is 0 to 4 means 0 closed, 4 open. 4 to 8 means from 4 closed to 8 open. All right? So if we follow this technique, this means 0 to 4 means 4 is not included here. So how many numbers do we have from 0 to 4? We have 2, 3, only 2 numbers. 4 to 8 means, or you can do it in this way, right? 4 closed, 8 open, 8 closed, 12 open, closed, open. All right, 0 to 4, 4 to 8, so we have 4 numbers between 4 and 8. 8 to 12, we have 8, 8, 9, 10, 10, 11. So 12 is not included, so we have 6. 12 to 16, we have 5. 16 to 20, 20 should be in the next interval, but you can include it here. It doesn't affect a lot. Or you can just write 2 here, and the 20 to 24, just make it 1. I think that's fine. You can just leave it in this way. So we have 2, 4, 6, 5, 3. To make sure that your calculations are correct, calculate the sum of the column. So 2 plus 4, 6, plus 6 is 12. 12 plus 5 is 17, plus 3 is 20. And this is the total numbers of students. We have 20 students, so we are good. Now, relative frequency equals the frequency divided by n, or you can say f over n. So the frequency is 2 divided by n is 20, 10%. So you may write 0.10, or you can write it in this way, 10%. Both are fine. 4 divided by 20 is 20%, or 0.2. 6 divided by 20 is 30%, 0.3. 5 divided by 20 is 1/4, or 25%. 3 divided by 20 is 0.15. So to make sure that everything is good, if you calculate 0.3, 0.36, 0.85, so the answer is 1. So the total here is 1, and the total here is 20. So we are good. So this is called a frequency table, and the last one is called relative frequency table. So the question is, create a relative frequency histogram, which means I have to create my histogram based on the relative frequency table, which means we have the relative frequency or the proportions in our y-axis. So what I do is the following. This is x. Sorry, it's not straight. Anyway, so this is x-axis, which is hours, right? This is hours. And y-axis is the relative frequency. So this is relative frequency. All right, so the relative frequency, the smallest is 10%, the maximum is 30%. So maybe I can start with 0.5. I mean 0.05, like 5%, then add 5% each time. So maybe something like this, 0.05. Okay, here 0.10, 0.15, 0.20, 0.25, 0.30, right? And then we have the intervals here, like 0 to 4. Let's say this is 0. The intervals, they have the same size. So 0 to 4, let's say 4 is here. It should be the same size. 8 is here. 12, 16, and 20, right? And then I create a bar represents the proportion or the relative frequency of each interval or of each pin. So 0 to 4, the relative frequency is 10%. Okay, so %10 is here, right? 4 to 8, the relative frequency is 20%, so 20% is here. So there is no space between bars. In the next session, we will learn bar chart. In bar chart, it's used for categorical data, and we should have space between the bars so they don't touch each other. 812.3, so you have to go up. 0.3 is here. 12 to 16, 0.25. 0.25 is here. Sixteen to 20 is 0.15. All right, so this is our histogram. It looks like a symmetric histogram, right? It's not 100% symmetric, but it looks like a symmetric histogram. All right, so this is how we create the histogram. Now, if I ask you create a frequency histogram, the final answer or the final graph should be very similar to this. In x-axis, we have hours, we have the same interval. In y-axis, we should have not relative frequency, we should have frequency only, where we have like 0, 1, 2, 3, 4, 5, 6. So we should have the same x-axis, it should be the same shape, but y-axis is slightly different. So this is the difference between frequency and relative frequency histogram. That's it. Thank you very much for watching.